Hello everyone. Very good evening one and all. Welcome to Wallah and welcome to the session. Join the session quickly guys and please confirm, am I visible and audible clearly or not in the chat box? Am I properly visible and audible? Hello 𝐂𝐤𝐧𝐤𝐬 CSE. Good evening. All the others, please confirm your presence in the chat box and also my visibility and audibility so that we can start today's class. So guys, we have started our GATE academic classes on our Wallah English channel with this data structures subject. Till now 3 classes are already done, and by chance you missed any of them, they are available in the playlist. After this class or whenever you get time, you can actually go through them, right? And today we are going to discuss this concept, array as a pointer. How array can be used as pointer. Today we will be discussing this. So without any delay, let us get into the session. In the last class, we have discussed about 3-dimensional arrays. We know arrays are classified into 1-dimensional and multi-dimensional. Under multi-dimensional, this 3D array, 3-dimensional array will be coming, and we have discussed how we declare a 3-dimensional array and how we initialize 3-dimensional array and how do we actually find the element to access it. So how we access element of 3D array means how the actual indexing happens in 3-dimensional array we have discussed, and then how to find address of 3D array element. This also we have discussed, right? I believe whoever have gone through this lecture, the last lecture, all the concept that we have discussed about 3D arrays is clear for everybody. And today we will be discussing, as you have seen the title, array as a pointer. That means first we will try to understand what is a pointer and what is an array quickly. Then, is there any difference between array and pointer? If so, what is the difference? If not, are they really same? And then array used as pointer we will try to understand, and this concept will be very useful in the GATE exam, dear friends, whether it is a C programming related question or data structure related question, because array is the common concept we have in both programming and data structures. For any kind of question, this concept array as a pointer will be very useful for answering GATE questions. So with all your confirmation, we will go ahead into the session. So please confirm, can we start today's lecture everybody? Are we good to go? Everyone, please confirm. Are we good to go? Hello Raj Sarkar. Hi Sheila Kumari. Okay, are you Nishu? Okay, great, great. Chaliye. First of all, we have discussed that an array, I have given 3 dimensions of definitions for array. What are they? One is very popular, that is group or collection of homogeneous or similar data. Group of homogeneous or similar data, that is an array. And another definition that I have given is, it is a variable. Like we have variables created using data type, array is also a variable, undoubtedly. But a variable store one value at a time, but this variable can hold, that can hold multiple values. Multiple values at a time. So in this way we can define an array. And what is the third definition that I have given to you? It is a reference. Array means what? A reference. Reference of what? Reference of group of similar data. So whenever I create some array, let's say int x of some 10, I need not to give any value for it. Let this array stored starting from the address, let the base address is 2000. If I try to print, x, just x, what will be printed? Means what I have used to print? The name of the array I have used. Name of the array indicates what? Name of the array indicates base address. So I will be getting the base address, as I have assumed the base address as 2000, it will be printing 2000. It will be printing 2000. That means array name is having what? Address. Array name is having what? Address. Right? Now, if we go for the pointer, how you define a pointer? It is again a variable. Like array is a variable, pointer is also a variable. What this variable can hold? The variable can hold address. It can hold what? Address. Address is nothing but reference. Again, address means we can say reference. Okay. Address of what? Address of any data. Any data. Usually we learn pointer means a variable that can hold address of another variable. It need not to be just variable, guys. It need not to be just a variable, because this can be a variable, this can be an array. Of course, array is also a variable. This can be function, it can be structure, it can be union, it can be file, it can be even another pointer also. So array need not, pointer need not to point to only one single simple variable. It can point to a variable, it can point to whole array, it can point to one element of the array, it can point to function starting reference address, it can point to structure or union or file or even another pointer also. So this could be the complete definition we can say for a pointer. Alright. Now if suppose I create int x is equal to 5 comma star p, and if I say p is equal to and x, let this x is having the memory allocated at 2000. Now what this pointer is holding? Address of x. That means this pointer is pointing to x. So now if we try to print, this pointer value, Raj Sarkar, sir, like for int we have to define int pointer, so for structure we need to define structure pointer. Acha, you are calling it as a pointer point to integer. Structure pointer means a pointer pointing to structure. Function pointer means pointer pointing to function. Array pointer pointing to whole array. Yes, we use the data type because arrays are also kind of data types, secondary data types we say. So definitely we use. Yes, what you meant is correct. Okay, fine. So here when I try to print the pointer value, what will be printed? Again the address 2000 will be printed. That means if we want address, we have two ways here. One, I can use array name, or I can use pointer name. Fine. Sir, here you are pointing this to a normal variable. Okay, now you see this example. Suppose I am creating an array x of 10, comma, one pointer p. Now, what I am doing is p is equal to x. Let this array base address is 2000 and p is holding this 2000. Now when I try to print x, when I try to print p, what I get? I will get the same output. For x I get 2000, for p also I get 2000, isn't it? So now the question is, so pointer can be replaced with array or array can be replaced with pointer, because both are however printing the same address, giving the same output. So can we replace them? Can we say both are exactly equal to each other? What do you people say? Nishu, Raj, everybody, whoever are watching, could you please respond to my question? Can I say pointer and array both are exactly equal to each other? Because whether I print pointer or whether I print array, I am getting the same address, same output. We can replace? Sure? Oh, okay. But actually not. Actually not, guys. We have to say that array and pointer are equivalent. Array and pointer are equivalent or similar, but not exactly same. But not exactly same. Sir, what is the difference, sir? I am getting the same output. Then how come you are telling both are different, sir? Come on, I am coming to that point. Listen carefully. Listen carefully. You will get proper idea. Proper idea now. See, there are two arrays. Int x of 10, comma y of 10. Okay? Listen carefully, beta. सब लोग ध्यान से सुनो. X of 10 is equal to, let's say, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Y of 10 is equal to, let us say, 10, 20, 30, 40, 50, so on to 100. ठीक है? Now, I am taking one pointer P, another pointer Q. I am holding the address of X in P, address of Y in Q. ठीक है? Now, if I am taking these arrays, like what is X array? This one, and Y array, this one. Both are having 10 as size with values 1, 2, 3, 4, 5, 6, so on. Just have little patience, please. 10, 20, 30, 40, 50, 60, 70, 80, 90 and 100. So this is X and this is Y. Let us suppose X base address is 1000, Y base address is 2000. Okay. Let one integer size is 4 bytes. As we are taking C language, integer size is compiler dependent, hence I am assuming it as 4 bytes. So we know how the addresses would be, right? 1004, 1008, so on, 2000, 2004, so on, right? That I am not writing. Now, when I am pointing P to X, Q to Y, P is holding what? 1000. Q is holding what? 2000. That means P point to X, Q point to Y. Till this it is very much clear, very much straightforward. Now, can I write X is equal to Y? Is this legal? Like I wanted to make all x values as y values. I would like to make all x values as y values. X array size is 10, y array size is also 10. Then no issue, no? I could be, but actually it is invalid operation. What? It is invalid operation. Okay. Now you tell me, can I write P is equal to Q? Can I write P equal to Q? That means where Q is pointing, there P also point. That means P and Q both pointing to Y. Both pointing to Y. So here you got one difference. Here you got one difference. What is that? What is that? The first difference is array is a constant pointer while pointer is variable in nature. Array is constant while pointer is variable. Do you understand this meaning? Both are printing the same address, so both are same means no. Both might be holding the address, but array always hold the same address, but pointer need not to hold the same address. Pointer need not to hold the same address. Sometime pointer can hold 1000, sometime 2000, sometime 1008, sometime 2012. We can change the value of a pointer. Right? So this is one difference you can clearly understand. And another difference, let us see. Int x of 10 is equal to 10, 20, 30, 40, so on to 100. Okay? And I am taking one pointer P, which is holding x. Another pointer Q, that is also holding x. That is also pointing to x. So, I am having the array of 10 in size with these values. Array name is x and these are the indices. Now, let us suppose the base address is 1000 and one integer size is 4 bytes. So, the addresses are 1000, 1004, 1008, 12, 16, 20, 24, 28, 32, 36. Now, what I have done, P, I am pointing to this x, Q, I am pointing to the same array. Now you see, Suppose if I try to print P, if I am trying to print P like percentile D comma percentile U comma, why I am writing U? Because I am printing the address. So I can use percentile P or percentile U, that is indicating unsigned integer. Unsigned integer. So when I write percentile U comma X, percentile U comma P, percentile U comma Q, what I get? What I get? Base address. All will be giving what? Base address. Great. Now if I say P plus plus Q plus plus, what I did? I have applied increment operation on pointer. Now if I try to print these P and Q values, if I try to print this P and Q, what will be printed? What will be printed, everyone? Can I have your response for this, please? Meenakshi, Nishu, Raj, everyone. Okay. So here when I say P plus plus, it is actually what? P is equal to P plus 1. That means 1000 plus 1 multiplied by 4. That is 1004. Why? P is pointing to an element of array, just an individual element of array. But when I say Q is equal to Q plus 1, Q is equal to Q plus 1, Q equal to Q plus 1, this would be 1000 plus 1 into total array size is 40 bytes. So this would be 1040. Why total array? The point is here. Look at this. You might be getting this doubt, sir, X and X both are same, no? X means base address and X also means base address, no? Then how does it matter? It matters when you put it in the pointer. When you say and X, you are referring whole array X. When you just say X, you are referring just an element of X, just an element of array. When you say and X, you are referring whole array. So Q is pointing to not just one element but the whole array. While P is pointing to just one element of array. Yeah, we will come to that. We will come to that 2D array. Okay, wait a minute, Nishu. So it is very much evident that a pointer can point to one element of array, or a pointer can point to multiple elements of the array. Right? See, now we got another thing. A pointer may point to either an individual element or total group of elements, but array always point to what? Array always point to what? Array always point to what? Individual element or group of elements? Array always point to what? Individual element or group of elements? Individual element. Array always point to individual element but can refer multiple elements or group. Can refer all the group. But at any given time, array name will give you any one element reference. But it doesn't mean it lose other elements. It doesn't mean it lose other elements. See, I am holding 10, but you ask me at any time I can give you 1 only. But I am having 10 with me. Okay? I am having 10 with me, but I can give you any one among them at any time. Anyone you ask. But pointer can have one or all the group. So using pointer, you can take any one, or you can access all the array, or you can just skip to whole group. Skip the whole group. So this is one more important thing you should understand between array and pointer. Another difference is about arithmetic, about operations that we can perform on array and pointer. Like on pointers, we will be able to perform increment operation. We will be able to perform decrement operation. I mean to say plus plus, minus minus. We will be able to perform addition with integer constant. Addition with integer constant. Something like plus 9, plus 4, like that. Plus some value. Similarly, hi Sudeep. Wait, Raj Sarkar, wait, let me come to that. Yeah, can we do subtraction with integer, guys? Can we do subtraction with integer on pointers? On pointers, can we do subtraction or not? Definitely yes. Definitely yes. Subtraction, that too with integer constant. And can we do assignment operation? Yes, with the same type pointer, or with the address we can do assignment operation, right? And can we do comparison, like can we apply equal to, relational equal to? Can we apply relational equal to, like is P equal to Q or not, or P not equal to this or not, or P star P equal to this or not, that or not? Can we do that? Yes, we will be able to do relational equal to or not equal to, and we can also subtract. We can also subtract two similar pointers. You can actually do this, like if P and Q both are pointers of same type, it is valid to do P minus Q, P minus Q, but addition we will not do. Addition of similar pointers we will not be able to do, but subtraction, yes, we will be doing. Now, these many operations we are able to do on pointers, but when it comes to arrays, first will I be able to compare two arrays equal to, not equal to? Will I be able to do comparison? No, I cannot compare. Will I be able to assign one array to another array, like x is equal to y? Just now we have seen. Not an element of array, that's what I am telling. Array, just array, not an element, just an array. Using array name, will I be able to do the comparison, like A equal to B or not? Let x and y are two arrays. Will I be able to do x is equal to y or x not is equal to y? I will not be able to do, right, Raj Sarkar? Similarly, I will not be able to assign, right? And can I do addition or subtraction on arrays? I will be able to do on elements of the array, but not directly with the array. As an array we cannot, like x plus y or x minus y, or you can say x plus 3. This is actually valid, like x plus 3 is actually valid because it refers to the address of third index element. Okay, so addition, subtraction we will not be able to do. Right, and will I be able to perform increment or decrement? Will I be able to perform increment or decrement? No, because increment means you are adding and storing in the same. X is equal to x plus 1, y equal to y minus 1. But you know why all we are not able to do all these? Because array is a constant. So these are all invalid operations. These are all what? Invalid operations. You got another point? Yes. So first, array is constant while pointer is variable in nature. Second, pointer can point to either one element or group, but array always will refer single element, but it can hold multiple values. And and on pointers, what operations we will be able to do, on arrays we will not be able to do all those operations. And finally, one difference I will be able to give you, that is pointer size is always unsigned integer size. ओके, अनसाइंड साइंड उसका कोई फर्क नहीं है in terms of size. So pointer size is always equal to integer size. But array size, what is array size? Will someone tell me what is array size? Suppose if I am executing or using 32-bit processor, I can say integer size is 4 bytes. On the same processor, I am using an array. Will someone tell me what is an array size? Yeah? Will someone tell me what is array size? Let me put it in this way. Pointer size depends upon integer size. Array size depends upon number of elements in it and their type. How many elements are there in the group and what kind of elements they are. If it is an integer group, float group, char group of same size, all the three will not take the same amount of memory. Similarly, one integer has 10 elements, another integer group has 5 elements. Though both are integer groups, both will not take the same memory. So array size depends on how many elements are in it and what kind of elements they are, both. While pointer size depends upon integer size. So now, what is the conclusion? Now you tell me, can I replace pointer with array or array with pointer? अब बोलो सब लोग, can I replace one with the other? When I asked this question earlier, everybody said yes, 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 can be replaced, can be replaced. Now what would be your answer? Nishu Kumar, the answer is yes. But if you are checking it in the online compiler, maybe your computer is 64-bit processor, but when you open the browser and you open some website, there you check size of int, it may print 4 bytes. Okay, it may print 4 bytes. I have to tell size of integer is compiler dependent. So what bit compiler you are using? All the online compilers today mostly are 32-bit compilers. Hence, you will be getting it as 4-byte. If it is a 64-bit compiler, you will be getting it as 8. But if you are using a standalone compiler, like it is not online, you have installed some Turbo C or ANSI C or Borland C or Dave C, some C you have downloaded and installed. There when you check, it is based on your machine compiler configuration. Again I am telling, let's say you are using 64-bit processor and you have downloaded 32-bit compiler. Now what is integer size? 32-bit. Because on 64-bit processor 32-bit software run. Because backward compatibility, isn't it? But on 32-bit processor 64-bit software you cannot. That we all know. So if your system is 64-bit and you have downloaded 32-bit compiler, there it is 32-bit. So usually processor configuration, compiler configuration usually will be same. Even the browser also automatically detect our processor configuration and suggest that particular configured compiler only. That's why we feel like anyway it is same, but it is always compiler dependent. Got the point? Got the point? Nishu Kumar and everyone. Integer size is always compiler dependent. And pointer size is equal to integer size, whatever maybe it is. Okay. So, from all these four, at least these 4 points, we can conclude, one is enough actually to conclude, but I have listed 4. Hence, arrays and pointers are equivalent. Again I am writing the same statement. That means in the usage, while you access the element, how you access the element using array name, in the similar way you can access the element using pointer name. But as because of that, they are not same. But not exactly same. Okay? They are just equivalent. Yes. I will give you one simple example. Why they are equivalent? Then why we are using the term equivalent, sir? Why not different? You see now. Int x of 5 is equal to, let's say 11, 22, 33, 44, 55, comma star p. Assume p is equal to x plus 2. Okay? P is equal to x plus 2. So what I have taken? An array of 5 elements, an array of 5 elements with the values 11 to 55 with the indices 0 to 4 . Let the base address be 1000 and one element size is 4 bytes. Now x plus 0 means what? 1000. X plus 1 means what? 1004. X plus 2 1008. X plus 3 1012. X plus 4 1016. Now what I have done? P is equal to x plus 2. So pointer P is holding 1008. Now, if I print, like if I say X, what I get? 1000. If I say X plus 2, what I get? Address of X of 2. Address of X of 2, which is 1008. 1008. Now, if I say star X plus 2, what is X plus 2 means? Address of X of 2. Mathematically we cannot say like that, but actually star and are complementary. Actually to write like this, actually it would be maybe if I write like this, I will be proved to be non-C language familiar, but non-mathematic familiar. But just for understanding, I can say these are complementary in meaning, because star gives you the meaning value at address, and gives you meaning address of value. So they are like complementary just in the meaning. Okay. So what you are getting? Value at address 1008, that is nothing but value at index 2, that is nothing but X of 2. Right. Now, similar way, if I say P, what I get? 1008. P plus 2, what I get? When this is P, P plus 0 means 1012. Sorry. When this is P means nothing but it is P plus 0. P plus 1 means 1012. P plus 2 means 1016. So what would be P plus 2? 1016. That is where P is to its next second element address. To its next second element address. Similarly, if I say star P plus 2, value at that address, that is 55. Right. So in the usage, actually how you are using array name, similarly you are using pointer name. To print the address of some element or to access the value of some element, we are using the same. Hence we can say if X is an array, P is a pointer. Let X be an array, P be a pointer. That is what Raj Sarkar I was telling. P need not to point to always the base address. P can point anywhere, but X always points to base address. P can point anywhere. And it is not P base address. You should not say base address of P. Base address of P means P got some memory, no? Pointer P is also stored somewhere. So base address of P, let us say P got 4 bytes at address 3000. Base address of P means it would be 3000. So don't use the term base address of P. P is pointing to some address of array, of an element of array, that need not to be the base address of array. Right. Okay. So let X be array, P be pointer, then X plus I, and let P is pointing to X. Let P is pointing to, if P points to base address, X plus I or P plus I will give you what? Address of X of I. Similarly, star X plus I or star P plus I will give you what? Value X of I, or you can also say P of I, or you can also say I of X or I of P. All are same in the meaning. So, with this lecture, I would like to make you clear about what is pointer and array. So, array as pointer means, yes, array you can use as pointer, but we have to handle it properly. Hope I am clear? Am I clear with everyone? Yes? So, in this lecture, we tried understanding array versus pointer. Maybe something like CSK versus RCB, or your favorite two teams in IPL. Both are almost equally powerful, but based on the context, based on the scenario, based on the situation, we will be giving the priority for either. So, array versus pointer means array is basically constant while pointer is variable. And array always hold base address while pointer need not. And all operations that you can perform on pointers, you cannot do on arrays. And pointer may point to one element or multiple, but array at any given time will point to one element but can hold multiple. Array will refer to one while holding many. So, these are four important points, important takeaways from today's class. Hope now if any confusions, yeah, Raj Sarkar, you are correct. Fine, great. So, if at all you have any confusions with respect to these, I believe with this lecture they are clear now, right? And with this lecture, the understanding towards arrays and pointers increased. Definitely you have some new learnings today, right? Gate easy CSC definition means you are just, see, definition term you can actually use for functions array, variable, for all the data. Data is being defined means it is properly created. It is properly created, right? But initialization means while creating, if you are assigning the values, then you call it as initialization. Okay? Oh, I am not updating this. The next topic is stack using arrays. Stack using arrays. Like we all know stack. Now we will try to understand how we can easily implement stack as an array and what are the pros and cons. Hope you guys are actually liking the lectures, and as the classes progress, I will definitely include gate questions also. It is not just theory classes, I will include gate questions also related to the topics that we discuss. Okay? Chalo guys, see you in the next class, that is tomorrow sharp at 7 p.m. Keep attending the lectures regularly. That regular learning is, consistent learning is very important, and you can actually bring your friends also, because it's a free class, they will be benefited, right? So I wish you all a very happy learning and happy coding. Thank you all. Have a great time. Good night. Bye bye. Jai Hind.